Okay. Right, now let's get the velocity. Velocity is the derivative 6t squared minus 6t minus 12, and the acceleration is 12t minus 6. And let's figure out when they're both 0. So the velocity 0, well, that means we'd have to solve this equals 0, which means t squared minus t minus 2 equals 0. So it's t minus 2, t plus 1. So if we were to graph that, velocity time, that's 2 and minus 1 are the two times it's at rest. Okay, and likewise for the acceleration. When is the acceleration 0? That's when t minus 6 equals 0. So that's when t equals 6 over 12, which is a half. So this is linear upward graph. So there's the acceleration, there's the time, and then at a half then, and here's the graph. So speeding up is when you have a positive velocity and a positive acceleration, or a negative, or, just linking these two, or a negative velocity and a negative acceleration. So a positive velocity, that is when the v is positive and the a is positive. So the only place where both of those would be positive would be t more than a half, or when they're both negative. So negative here underneath and to the left. So to the left of a half. So between minus 1 and the half. And then slowing down, that's when the velocity is positive and the acceleration is negative, or the velocity is negative and the acceleration is positive. So velocity is positive and the acceleration is negative. So positive velocity is here and here, and the acceleration is negative, is less than a half, so it would be less than minus 1. Or when the velocity is negative, which is between minus 1 and 2, but the acceleration is positive, so that's more than a half, but it has to be less than 2 still. So just putting that together, more than a half, or between minus 1 and a half. So I guess, could you include the half as well? Interesting question. And slowing down is a bit different. Doesn't look like includes the half. So I feel like I might have made a mistake with my half and 2. So let's just double check it. Velocity positive and acceleration is positive. So that has to be more than 2. Aha. And I said more than a half, didn't I? 2 is bigger than a half, so it has to be more than 2. Or velocity is negative, which is between minus 1 and 2, and acceleration is negative, which is less than a half. So yeah, okay, so that looks better. That looks better. And let's check the other one. Velocity is positive and acceleration is negative, so it has to be less than a half, so less than minus 1. And then velocity is negative, so between minus 1 and 2, but acceleration is positive, so between a half and 2. So the speeding up answer would be from minus 1 to a half and union to infinity. And then the slowing down would be minus infinity to minus 1 union a half to 2. Okay. I think these sets should be open, but you could make the case that it could be closed as well because closed at the, like if a car's at rest and it accelerates, it's speeding up. So you could make the case for equal sign here, which means you would include the -1 and 2. So, you know, you could have it like this. Likewise here. So you would include the -1 and the 2. I don't feel like including the A as 0. Then you might have to look at the third derivative. So I guess in the third, you know, that might be too complicated for what they want. Let me just check the answer here for the next one, 151. So, no, it doesn't look like they keep everything open, it looks like. So, yeah. I just feel like you could make the case, though, because if a car's at rest and it has a positive acceleration, it is speeding up. So, I don't know. Yeah. Although maybe in English, would you say car speeding up if it's starting from rest or just that it's beginning to move? Maybe speeding up's not quite the right term. Yeah. Yeah, interesting grammar point. Okay, let's have a look at the next one. 151. So the velocity is 6t squared minus 30t plus 36, and the acceleration is 12t minus 30. And let's plot the velocity and the acceleration. So acceleration is easy. Same deal here. When this equals 0, it's 30 over 12. That's 5 over 2. 15, yeah. And then this solving this quadratic, well, you can divide it by 6, by the way. So that's 6t squared minus 5t plus 6. So that would be 6t minus 6t plus 1. Is that right? Let me check. No, I've done something wrong here. Oh, plus 6, sorry. So yeah, that's the wrong factorizing. 3 and 2. Okay. So here at 2 and 3, and we've got our quadratic. Okay, so speeding up, we'll need bt to be more than 0, at to be more than 0, or bt less than 0, at less than 0. So for the velocity to be more than 0, and the acceleration to be more than 0, so it has to be more than 2.5, and it'll have to be more than 3. So together this makes t more than 3. Or it has to be negative, so between 2 and 3, but less than 2.5. So between 2 and 2.5. 2.5. So that answer there is 2 to 2.5 union 3 to infinity. Let's check the back for that. 2 to 2.5, 3 to infinity. Okay. And then slowing down, well, it'll just be the other situation. The velocity is positive, but the acceleration is negative, or the velocity is negative and the acceleration is positive. So positive velocity, but a negative acceleration. So has to be less than 2.5. So less than 2 would do it. That positive, but that one negative. Or a negative velocity between 2 and 3. So between 2.5 and 3. So that would be minus infinity to 2 union 2.5 to 3. Okay, let's see. Oops, 0 to 2. Oh, yeah. I guess they're not allowing negative time here, of course. Yeah, funny. I mean, it's obvious, but it's not explicit in it. Um, yeah, no negative time. So yeah, okay. Yeah, I forgot about that. I was thinking too mathematically. Okay, yeah, so that's right now. 0 to 2, 2.5 to 3. Yeah, okay, funny. I better check back on 150. I hope I didn't have a negative time answer in there. Let's have a look. Hope not. Ah, I did. Yeah, I did. Silly me. 0, 0. Okay. Silly me. Silly me. Well, I don't feel too bad about that because I don't know, like the question doesn't explicitly say that the particles begin moving at t equals 0. So um and in fact, maybe we should entirely forget about this answer here because it has the -1 in it. So I should just completely get rid of that. I have to assume t is greater than or equal to 0. Should I include the 0? Maybe not. Maybe not. I don't know. Okay, I'm gonna just pause for a few seconds to leave that on the screen. Yeah. Okay, so I think they're okay now. All right, let's try 152. Yeah. Okay. Okay, that should be long enough now. Let's have a look now at 152. I really wish they said in the question t more than or equal to 0. Oh well. Oh well. 152. Okay. St equals t over 1 plus t squared. So that means Vt, velocity, is the bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom. So that would be 1 t squared minus 2t squared. T squared minus 2t squared. So that's minus t squared all over 1 plus t squared squared. And then the acceleration would be the derivative again. So I think what I'd like to do is actually expand out the bottom. So the velocity will be 1 minus t squared over 1 plus 2t squared plus t4. And the acceleration would be the bottom squared. And then the bottom times the derivative of the top. So that's minus 2t times 1 plus 2t squared plus t4 minus the top times the derivative of the bottom, 4t plus 4t cubed. It's looking messy. So AT on the top is minus 2t minus 4t cubed minus 2t5. Oh dear. This is going to be awful. Awful, awful, awful. Unless stuff really cancels out. Oh, hang on. Maybe we can be smart about this. Maybe they're trying to trick us into doing it this way, but there's a smarter way to do it. Yeah. Hang on. Since t is greater than or equal to 0, that means st will be greater than or equal to 0. But if we have to use only open sets, not including when it's at rest, i.e. ignore that it starts at rest, then that would mean that st is always positive. And I wonder if we calculate the bt again, I shouldn't have removed it. It's the bottom squared, and then the bottom times the derivative of the top minus the top times the derivative of the bottom. So that's 1 t squared minus t squared over 1 plus t squared squared. And we only care about the sign. So that's 1 minus t times 1 plus t over 1 plus t squared squared. Okay. And the bottom, I wonder if we can ignore it. I wonder if we can ignore it because it's not going to affect the sign, which is all that we really care about, not the magnitude. In fact, also, the t is more than or equal to 0. So this is never going to be negative. So it all just kind of really hangs on this one here at the 1 second mark. So it's at rest again at 1 second. Yeah. 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 But since the ST is always positive, it never goes in reverse, right? If the ST is always positive, it's always moving forward. So, yeah, okay. And it comes to rest at 1 second. And then continues forward again. So it's slowing down up to the 1 second mark. Yeah, so I think I can kind of guess the answer, or not guess it, but it slows down. See, its initial speed when t is 0 is 1, but then 1 second later it's 0. So it slows down between 0 and 1, and then speeds up after that. More than 1. No answer at the back to check. Was that a bit too gutsy? Why don't we calculate it in some software here and see? Is it not loading? Right. ST defined as T over 1 plus T squared. Okay. So let's differentiate that with respect to T, and then differentiate that with respect to T again. So speeding up is when that is greater than 0. And actually, you know what? Let's make our life a little bit easier. So we'll define this as the velocity. We'll define this as the acceleration. And then we want to solve the system. Velocity is positive and acceleration is positive. So that's not in our set, okay? And then the other situation for speeding up is when the velocity is negative and the acceleration is negative. Oops. And that's between 1 and root 3. Yeah. Okay, so I might have to calculate it out longhand. Oh dear. And then that's speeding up as well. And then when we have them flip the other way, yeah, okay. Rats. Can't quite guess the answer. Where does the root 3 come into it though? All right, let's calculate the acceleration. Okay. Thought I could guess it. Acceleration is the bottom squared. Bottom squared, and then the bottom times the derivative of the top, which is minus 2t, minus the top, 1 minus t squared, times the derivative of the bottom, which is 2, 1 plus, I don't know if the chain rule has appeared yet, but you can expand it out if you want to, but it'll also work out to be the following, times 2t. Okay, so I can actually, yeah, I can ignore this because it's always positive, and I can ignore this because it's always positive, and I can ignore this, so it's always positive. So a simplified velocity function, I'll call it velocity, what could I call it? An alternative velocity. Not the correct velocity, but at least the correct sign. And likewise, an alternative acceleration. Would just be the top. Now, can I simplify it a bit? There's a 1 plus t squared in both. So I can take out 1 plus t squared. That won't affect the sign. So I can delete that, and I can delete the power there. I can get rid of the 2 from both. That won't affect the sign. I can get rid of the t from both. That won't affect the sign. So that's going to be minus 1 minus t squared minus 2 plus 2t squared. Oh, I'm starting to see where the 3 comes from. Minus 3 plus t squared. T squared minus 3. and 1 minus t. Very interesting. Very interesting. Okay. Okay, so we want, here's our picture now. So that's at the point 1, and that's going down. And then acceleration, or fake acceleration. And that's minus root 3 to root 3. So it's a graph like this. And this is the one we really care about. This is root 3. So speeding up, that would be when they're both positive. So that would be when it is less than 1 and less than root 3. And root 3 is, so just less than 1. So between 0 and 1. It's also speeding up when they're both negative. So that's more than 1, but less than root 3. 1 to root 3. Okay. And then slowing down. So I just want to check that I got that right. So when they're both positive and they're both negative. So both negative, I don't think that's right. I have minus 1 to 0. Okay, so let's just check that again. Solve system. Okay, so what was I going for first? Both positive has to be less than 1. Oh, yeah, that's my mistake. Less than 1, but more than root 3. So you can't have that. Yeah. So that's impossible, which corresponds to the answer I got outside the range. And then the other one is when they're both negative, which I think we got. Okay. Yeah, between 1 and root 3. Excellent. Okay. And then slowing down is when this one's positive, but this one is negative. So less than 1 and less than root 3. So less than 1. Less than 1 would make this positive, and less than root 3. So less than 1 then. Or it could be this one's negative and this one's positive. So more than 1 and more than root 3. Okay, union. Right, let's check this one. So opposites now. Okay. So we'll just flip this one around. Okay, and then more than, less than. So between 0, 1 and more than root 3. Between 0, 1 and more than root 3. Excellent. Excellent. Okay. So that's the answer there. Yeah, they were 3 tough questions. And like I said, I would have much preferred if they said this in the question, but anyways, there you go. Oh, sorry, and this is, yeah, 152. No answer at the back, but we've checked it in the software. And that's a very tricky question. My trick here was it's enough just to look at a function that has the same sign as the acceleration, and likewise for the velocity. If you don't care about the magnitudes, just when they change sign. Okay. Yeah. So I think I'll just finish by just making that a little note. So my trick would be to replace BT with BT such that they have the same sign. So the sign of BT is equal to the sine of BT for t greater than or equal to 0. So if you do a replacement like that, then the solution will be the same. For example, if you had something like bt equals t squared, or t power 4 minus t squared, well, that's equal to t squared times t squared minus 1. You don't really need the t squared here, because that's not going to ever affect the sign. It's only this part here where signs could change. So you could replace it with this formula instead, t squared minus 1. And yeah, it's a different graph, but it will cross the axis at the same point. So I'm sure there's a word for that trick. I'm not sure what it is. Very tough questions today. Now we're getting into real meaty stuff. So well over time, but hopefully worth it. Thanks for watching. Any problems, do please let me know. And we'll leave it there for today.